So Algebra 1.
Algebra.
That's what Algebra, since we only got bros in here today, right?
Yeah.
So this is lesson 92, uniform motion problems about equal distances. When we talk about motion, the rate equation is something that we need to be familiar with. Does anybody know what the rate equation is? No? Does anybody besides Tad not know what the rate equation is? Yeah? You don't know it either? Caleb doesn't know it either. Okay. Nobody knows. Wow. All right. I wonder if we've covered it previously in the book. Let's see. Let's see. Rate is on page 384. Good news, guys. We haven't covered it before, so you guys are off the hook. Okay. All right. So here's what I always use. Here's what I always think of in my mind to remember the rate equation. Very easy. Look at your speedometer on your car. What does your speedometer measure your speed in?
Meters or miles.
Miles per hour. Right?
Per second.
So if I'm going 55 miles per hour, that is my rate of speed. All right. So given that, what do you think rate could maybe be? It's a fraction. What do you think goes on the top of that fraction if it's miles per hour that my rate is measured in?
Miles.
Okay, miles is a unit of what?
Distance.
Distance, right? So for the rate equation, distance goes on the top. Rate equals distance over
Time.
right? So hours is a unit of time. So that's it. That's the easy way to remember it, right? It's your rate of speed, it's your miles per hour, it's the distance over time. So we're going to use this particular equation. It's going to be helpful in chapter 92. It's going to be helpful in chapter 94. In 92, we're looking at rate problems where the distances are the same. So you're going to have scenarios where someone's traveling to a location, so a certain distance, and then maybe they travel to the location at one rate, and then they come back and they travel at a different rate. But the distance was the same, right, between the two locations. Or maybe it's two people that leave at different times to get to the same spot, and but the distance again is the same. So that's what these problems are going to look like. So in the first example, it says that on Tuesday, the express train made the trip in 12 hours. On Wednesday, the freight train made the same trip in 16 hours. All right, so if it's the same trip, and we're thinking about the rate formula and the things that are involved in the rate formula, if it made the same trip, what's going to be the same about the two trains? They traveled what? The same distance, because they made the same trip. Does everybody see that? It doesn't explicitly say that in the problem, but because it says they made the same trip, then that means that they traveled the same distance. Now, in order to do these when the distances are the same, it's going to be helpful to rearrange this equation and solve it for the distance. So we can think of the rate equation as r equals d over t. How would I rearrange that if I'm solving for d?
R times T equals D.
Yeah. So distance equals rate times time, right? Or to use just the big letters, d equals RT. Okay? So in our case, they travel two different, there's a D1 associated with the express train, there's a D2 associated with the freight train, but D1 and D2 are equal to one another because they travel the same distance. So what it wants us to do is find the rate of each train if the rate of the freight train was 15 kilometers per hour less than the rate of the express train. So let's write down what we know. So like I said, we've got two different. We've got the express train. Let me use a different marker. Let's try the black one. So we've got the express train that is, and then the freight train, right? So for the express train, we're told that it made the trip in 12 hours. So the time for the express train, we'll just put a little e there for the express. The time of the express train was what? 12 hours. What was the time for the freight train? Hudson doesn't have a book. And he's dressed like a strawberry. This is forever recorded on my YouTube channel. Hudson, you have anything to say about that?
Spin the camera.
He did give me a lollipop though, so.
Do you take hush money?
Edit that part out of the video. Okay. What's the time for the freight train? Are we told? Look at the book. What is it?
16 hours.
16 hours, right? So 12 for the express, 16 hours for the freight train. And the other thing that they tell us is that the rate. What's the rate of each train if we know that the rate of the freight train was 15 kilometers per hour less than the rate of the express train? So we've got two rates. We've got the rate of the express and we've got the rate of the freight. Can anybody give me an equation that relates the rate of the express to the rate of the freight based on what it says right there? If the rate of the freight train was 15 kilometers per hour less than the rate of the express train? Any idea? I need an equation that has rate of express and rate of freight in it based on that fact. Yep.
RE minus 15 equals RF.
RE minus 15 equals RF.
Oh, hold on, let me check that real quick.
So it says the rate of the freight train was 15 kilometers less than the rate of the express train. So which one, based on this formula here, which one's going to have the lower rate?
RF.
RF, yeah. So that looks right to me, right? RF is 15 kilometers per hour slower than the express train. Does that make sense to everybody? So now we've got this equation, we know these values. The other equation that we're going to use is based on this right here. Because based on that right there, we know that the distance of the express train that the express train travels is going to be DE equals RE times TE, right? The distance that it travels is going to be the rate of the express train times the time of the express train. And for the freight train, DF is going to equal RF times TF. The distance the freight train travels is going to equal the rate of the freight train times the time of the freight train. But what do we know about these two distances again? What's true about the distance that they travel? Yep.
They're the same.
It's the same. They're making the same trip, right? So we can actually set this and this equal to one another. Does everybody see that? So we have another equation right here where we say RE times TE has got to be equal to RF times TF. And so then we just start plugging in values. Thank you. Ugh. We start plugging in values that we know. All right? So we're going to change this by plugging in the time, the two times that we have. So if TE is 12, then we can rewrite this side as 12 RE. And this side we can rewrite as 16 RF. Make sense? So this is really our two equations with two unknowns. If we think about having a system of two equations with two unknowns, that's our two equations that we're gonna solve. Use to solve RE and RF. Yes.
Would you not substitute the RF?
So take this value here and plug it in for RF.
Mhm.
Yep. So I wanted to highlight the fact that once we do all of that, we've got two equations with two unknowns, and so now we can use our normal methods for solving those. What are our two ways that we solve two equations with two unknowns? Say that again?
Substitution and elimination.
Substitution and elimination, exactly. So what Caleb recommended is let's use substitution, because this is already solved for RF, right? So I can take this RF value right here and plug in this for it. So that means that 12 RE is equal to 16 times RE minus 15. And simplifying that, let's distribute the 16. 12 RE is equal to 16 RE times, oh wow, what is 16 times negative 15?
241?
What is it?
240 or 240?
240, is it?
I think. No, let me check.
6 times 5 ends in 0, so that sounds more right than 241.
Sorry, it was just automatic. So I was trying to calculate it as I was
Hmm.
saying it. Yeah, 240.
240, all right. I was thinking 15 times 15 was 225. So 240. And so let's get our REs on one side, which means we're gonna have 4 RE here, move our 240 over. And what's 4 divided by, what's 240 divided by 4? You math guys? Have these, don't need the calculator. What's 240 divided by 4?
60.
60, yes. So the rate of the express train was 60 what? Kilometers per hour, right? They gave it to us in kilometers. So km divided by r. So that's RE. And then we're going to take that value and we're going to plug it back in this equation, which tells us that RF is 15 kilometers per hour less, right? So RF then has to be equal to 60 minus 15, which is going to be 45 kilometers per hour. That's our other value. Cool? Any questions about that?
Is there any simpler way to do this?
What? No.
Expel them from the class.
Is
I
there,
mean,
would there be a faster way of doing this?
well, I mean, I was purposefully taking it slowly, right? Because it was our first time working through one of these. But like, if I'm reading in the book, I may not write these down. I may just go ahead whenever I do this equation here. I probably wouldn't have written these equations down. I would just go ahead and start with this one, RE times T equals RF times TF, since I know they have the same distance. And then plug in these values here. So, I mean, I could write down a little less, but I was writing down everything this time to make sure you guys are following.
Okay.
All right. All right. Any other questions?
Lessons are we doing this?
I think I need to switch markers because both of those are struggling.
How many
have a
lessons are we
question?
doing this week?
Say it again.
How many
How many lessons? Well, we started a little late, and we don't have everybody here, so probably not going to be a ton of information. All right. Peace out.
Maybe 2.
Maybe 2. Oh, I thought you were telling me peace. Okay.
Ah,
So where was your address again?
Because you're gonna egg my house, or are you gonna send me a wonderful thank you,
TP?
Mr. Walker gift?
Little TP. Film paper.
Not so expensive.
True.
I live in Alabama, so
No, seriously?
drive to the state and
Physical
look for it.
Are you an Alabama team or Auburn team?
Auburn,
Auburn.
definitely. Yeah.
No more Mr. Walker gifts.
Go AG.
What? Are you an Alabama fan?
No, I'm
Oh.
a Georgia fan.
Oh, well, I pull for
Go
Georgia as long as they
AG.
don't play Auburn, LSU, or Georgia Tech.
Go
So
AG.
things as long as I play a D team.
I mean, I've got connections with all those places, so.
Go AG.
Go who?
ANG.
What's that?
Air National Guard.
Oh, okay.
Is that a team?
Yeah, I pull for them too. They don't have
No,
football
it's
team
where-
though.
It's where his son
I thought
works.
that was a long.
So
I
didn't
mean,
you
I
say
guess
you
since
wanted,
they're
The
under the Air Force,
National
they do have a
Guard.
football team.
didn't you tell me that you wanted the Chiefs to win the Super Bowl last year?
That's
No,
Isn't that what I heard?
that is not what you heard. It was not. Okay, let's see. Let's do
50 question mark?
one more, but we're gonna do it the faster way this time, Tad. All right, we're gonna take just a tad of the time that we took before.
I hate when people do that. It happens so many times.
Really?
They don't realize that.
Is Tad? What's Tad short for?
Thaddeus.
Thaddeus. Okay.
Yeah.
Should I just call you Thaddeus? And then it
Please.
won't be
No.
tempted.
That's what I call
Please
it.
call
It
No,
makes
you
me
don't.
so
That's a
bad.
lie. That's a lie.
Well, can we pronounce it like Amadeus and call you Thaddeus?
Fabulous.
How about that? That's kind of cool.
That's
kinda
actually
cool.
cool.
All right, so Durant drove to the Oasis in 2 hours, and Medill walked to the Oasis in 10 hours. Where are these names from? So what is that? 2 hours and 10 hours. What are those? As we think of our rate equation, what are 2 hours and 10 hours? Distance, rate, or time?
Time.
Those are times, right? So we got T1, which is 2 hours. This is writing so much better. And we got T2, which is 10 hours, right? And how far is it to the Oasis if Durant drove 16 miles per hour faster than Medill? So the rate of Durant is, which was the first one, so R1, we've got R1 and we've got R2. If Durant drove 16 miles per hour faster than Medill walked, then where are we putting the plus 16? On the R1 side or the R2 side?
R2.
He's 16 miles faster per hour faster, so yeah, that 16's got to go over here. Does everybody see that? All right. Again, the distances are the same. So we're gonna, since we know that D equals RT, we're gonna say that means that R1 T1 has got to equal R2 T2. R2 T2.
What would that sound
That's
like?
close. Is anybody like a master R2D2 sound maker?
Miles.
Can anybody do the scream that it does when the Java like shoots it?
Caleb would probably do it.
All right, so let's do T2R1 equals 10R2. All right, there's our two equations. Does it feel faster, Ted?
A little bit.
So far? A little bit.
Yes.
All right, cool. Now, I think we should do substitution again. What do you think, Caleb? Already got R1 solved.
I like elimination though.
Right. So we're going to say 2R2 plus 16. Substituting in this R1 for this R1 right here, right? And so 2 times that equals 10 times R2. We distribute 2R2 plus 32 equals 10R2. Move the R2 over here. 8R2 equals 32. 32 divided by 8 is, yes? What?
It would be 4.
Okay,
But also,
yeah.
haven't we learned this just like with distance and time?
We have done this before. What's different about it this time? Does anybody catch what the difference is? Yep.
Instead of doing straight variables, we're doing it in a roundabout way, where we give each value and we're doing more problems for it.
Okay. I was going to say the difference this time is the distances are always equal. I don't know if that was the case when we did it before. But here it specifically says for this chapter we're dealing with equal distances. So that's kind of the key. We're always going to have, for these problems, we're always going to have this scenario.
So what's your
R1T1 equals R2T2.
What's your YouTube channel called?
Encode tutor.
Encode tutor.
That's right, spelled like this. E-N code
No.
tutor. Alright?
No.
There you go. Are you going to be my 37th follower?
I don't know, man.
I
How
think
much
I'm
does it
gonna be
pay?
your 37 follower.
Okay. Question.
You have what?
I got -4.
Oh no. What happened, Caleb? How could this have happened, man? Does this all look right to you?
Oh, I switched the 10R2 to the other side.
I mean, if you did that, you'd get a -8 over here. But you have to move the 32 over, which also becomes negative,
Oh, I just didn't make it negative then.
right? And what is this rate going to be?
Hey man, we're good.
This was in miles per hour, so this is miles mph. And what did they ask for? They asked for how far is it? Oh, actually, they wanted to know how far it was to the oasis. So this is not our answer. How do we figure out how far it is to the oasis? Do you know? Or,
Can I go to the restroom? Or specifically to the water fountain?
well, hang on just a minute. Let's do this last little part, all right? If we know this is the rate, the second rate, how do we figure out how far it is to the oasis? In other words, what's the distance that the second individual traveled? Yep.
We multiply the wait. We find this. Wait, hold on. You just said
Remember this
something.
equation here?
Yeah. We would multiply our rate by our time.
By our time. So what was the time for that one?
2 hours.
Hmm?
So
This
we
is
could
our
say-
2,
Oh, 10 hours.
10 hours, right? That's why we write this at the beginning and label all that stuff so we don't lose track of it, right? So 4 times 10 means that the distance is 40, right? 40 miles. That's actually our answer for this problem. So that's important, right? If you have this on a test or quiz, just make sure that you pay attention to what I'm actually asking for. Okay, now you may go.
Wait, I'm sorry about that.
No, I'm just saying he may go to, he needs to wait till you write it down before he goes to the restroom.
Yeah, he
Right.
does.
All right, so while, you done? Everybody got it? Am I good to erase? Okay.
Wait, what's the final answer?
The final answer was this 40 miles.
Okay.
All right. All right, let's jump on over to lesson 93. Products of rational expressions and quotients of rational expressions. All right, so for problems like this, the key is going to be, let's simplify anything we can simplify before we actually do the multiplication. All right, so they give us a problem like this: x squared minus 25 divided by x squared minus 7x times x squared plus 3x divided by x squared minus 2x minus 15. All right? All right, so this looks really ugly, right? What would be involved if I wanted to do this multiplication? What if I didn't simplify? There's a way to simplify it. We'll talk about that in a second. But if I was just going to multiply it exactly like it is, then how does multiplication work with fractions?
Could we cancel?
That's the simplifying. We're not going to talk about that yet. All right? Yep.
We subtract.
You subtract.
You know,
Yeah,
When you multiply in fractions?
multiplying,
Not with multiplication. Division we do.
Oh yeah, it's the you swap it around.
Someone's had a
No.
long day.
If we
It
have
has been
this,
a long
if we
day.
have this
Okay.
times this, how do we do that?
You just multiply straight across.
I just multiply them straight across, right? This is 6 times 12, which is 1/2, right? So in multiplication of fraction, you multiply the numerators, you multiply the denominators, right? Do you guys see if we were to do that with this, that would be really ugly? I got a binomial times a binomial here, so I gotta use FOIL for these guys, and this here I've got a binomial times a trinomial. So distributing that's gonna be really ugly and take a while. So I like the simplification idea if we can do any factoring and canceling stuff out, right? So when we see something like this, the first thing we're gonna do is we're gonna say, is there some factoring I can do? You say yes, all right. Can I factor x squared minus 25? No? You guys don't remember the difference of two squares?
Oh, yes. So it'd be, yes.
Okay, what's our rule for the difference of two squares? If a squared minus b squared is the original problem, what does that break down into? You guys remember? Huh?
A plus B, but parentheses.
Right, a plus b,
Then in parentheses, A minus B.
a minus b, excellent, all right? So that means, for this one here, I can break it apart into a plus 5, and, I'm sorry, not a, x plus 5 and x minus 5, right? Because that's the square root of x squared and the square root of 25, right? So we can break that down like that. This guy, what can we do? Is there anything we can do factor-wise with the denominator in this one?
X.
X is common to both, so we can factor that out and change it to that. You guys cool with that?
No, I'm actually.
I know you guys are cool, but are you
I'm
cool
very
with that?
offended. I'm so offended.
Okay. You're offended?
Yeah, I am.
Oh, that I said you were cool?
No, about the problem I am.
Because I'm hot.
Oh, okay, so,
So-
alright. So moving right along, we'll edit that part of the video out. So what do we want to factor out of this guy? What can we factor out of that guy?
X.
Another x. Were you gonna say that?
X parentheses X
Uh-huh.
plus 3.
X plus 3, good. All right, excellent. And then over here, we can actually factor this guy into X. What would the product? The two terms that are a product of 15 be two factors of 15 that add up to
Positive
negative 2.
5 and negative 3.
You're so close.
Oh,
You're
yeah.
so-
Negative 5, positive 3.
Positive 3, negative 5.
That's right. So positive 3, negative 5, right?
Positive 3, negative
Because
5.
that's what adds together to get us a negative 2. All right, cool. So now when we do this, check it out. There's all kinds of stuff that'll cancel out. You guys see it? What can we cancel out?
X plus 3.
X plus 3 right here cancels out. What else?
I guess.
Remember, since this is multiplied together, it's like this whole thing is over one big
Oh,
fraction.
that X minus 5.
So
X
these will
minus
cancel out too. What else?
X's.
The x's will cancel out as well. You guys see that? Wow, this is so much simpler than what I thought it was going to be, right? Our answer ends up just being x plus 5 on the top and x minus 7 on the bottom. Super easy. But if we had multiplied that out, that would have been a pain. Yes.
That's the end answer.
That's it. We can't do anything further. There's no further simplification that's possible with that. All right, so if you see a nasty problem like that, like this, go, there's no way they want me to do that. I've got to be able to cancel some stuff out. So just start factoring and see what cancels out, okay? All right, now, what about division? Division's going to be the same deal. It's just, you guys said it just a moment ago, right? If I have this, x squared minus 2x divided by x squared plus 2x minus 8, and then all of that is divided by x squared plus 5x. Divided by x squared plus 7x plus 12. X squared plus 7x plus 12. So I've got this big rational equation divided by this big rational equation. And this is what you guys were telling me a moment ago. What am I going to have to do first before I do anything else in this one?
Flip it.
Flip it, right? When we divide by fractions, that's the same as doing what? Multiplying by the reciprocal, right? So let's rewrite this as x squared minus 2x over x squared plus 2x minus 8. The reciprocal is the flipped version of this, right? So we have x squared plus 7x plus 12 divided by x squared plus 5x, right? So that's actually the problem that we're going to do, and that's exactly what we did last time, right? So these problems really aren't any different. It's just you have to make sure before you start it, flip this guy and change this to multiplication. And then we'll do the same thing. We'll factor. We will, right, the top one factors into x over x minus 2. The bottom one factors into x, what is that, plus 4, x minus 2. This one factors into x, what is that, plus 6, x plus 1. No, x plus 2. That's not right. What is that one? 4 and 3. Sorry, so 4. So x plus 4 and x plus 3. And this one factors, we factor out an x and we get x times x plus 5. And so when we do all that, this cancels out, this cancels out, this cancels out, and we're just left with x plus 3 over x plus 5. I went through that really fast because it was just the same thing. Yes?
Wouldn't this work for only like certain problems? Like you couldn't really use this in life because you could get really different answers.
Are you saying in life this is never going to happen and be that easy?
No. Well, like you couldn't just like simplify everything. It's never gonna be like
Yeah,
that.
it's really just an exercise in making sure that we can do the logical steps to be able to simplify. You're right, real world stuff, this doesn't often happen, right? It's like if I just randomly make up a problem of values and then we do the math, usually we don't just get like a fractional number, we don't get a whole number, right? But often in here, we'll do these problems, like with the rate equations, we got whole numbers with all of those, right? Real world, it usually doesn't work out that nicely. So you're right. But just being able to do these logical steps is helping us understand how to simplify these things. And that stuff you are going to have to do in other math classes, so it's good to get good at that, right? Yep.
Couldn't we put a value for x where when we divide it, it equals 1?
So if you mean the top and the bottom are equal to the same thing? Is that what you're saying?
Yeah.
Yeah, sure. We can do that. Could we?
I think so.
Actually, I don't know. Could x plus 3 equal x plus 5?
No.
Actually, that won't work, right? When we start trying to simplify, the variables disappear and we get an untrue statement. So for this one, we couldn't do that actually. All right, let's move on to lesson 94, which is going to be back to our old rate equation, right? It's good that we're doing 92 and 94 in the same class because they are very much related.
Mr. Walker,
Yes,
If you were
Mr.
taking
Cunningham.
if you were taking Algebra 1, what would you take next? Algebra 2 or Geometry?
I would take geometry.
Yeah, because of that, I'm having to do geometry in the summer.
Ah,
Yeah.
bummer.
Why wouldn't you do Algebra 2 if you still freshly had Algebra 1 on your own?
Well, because you are going to use some geometry in Algebra 1.
You mean 2?
I'm sorry, you are going to use some Algebra 1 in geometry. But geometry is I think easier than Algebra 2. So I think having more time in a math class and just working through problems, I think some math maturity would be good before you jump into Algebra 2. Not everybody does it that way, and it's not always an option. Like this year, we didn't offer geometry. We only had Algebra 2 available. So if they took Algebra 1 last year, they had to go into Algebra 2 if they were going to take it here. But if I had the option, I would probably recommend geometry. I think it's easier overall. All right? Okay. Plus, if you happen to be a slacker in class, gives you another year to sort of mature and say, you know what? I'm about to have to be in college. I better straighten up, right? And start working harder. I'm going to be the class president. If I want to be the class president, I got to work harder. Lollipops are not going to get me through life. I'm probably thinking that, right? Yes.
What about trigonometry? Would that be necessary?
Is it necessary?
Yeah, like would you recommend taking it
Well,
in
so
high school?
usually they don't have a separate trig class now. It's usually like integrated into other courses. So you're going to be introduced to trig. Have we done any trig equations in here?
I don't think so.
Okay, so you're going to be introduced to it in geometry. You are going to see it in geometry. And you'll see a lot more of it in Algebra 2. So that's another good reason to take geometry first, because you'll just kind of be sticking your toe in the water with trigonometry, but you're not going to use it the way you will in Algebra 2. All right, let's do some uniform motion problems. All right. So what do they mean by that? Well, a southbound bus. This is example 1. A southbound. Well, let me just read the beginning here. It says in the uniform motion problems that we've worked on up to now, 2 people or things traveled equal distances. All right, so that's what we've had in the past, where we had the same distance traveled. But now, we might instead know what the total distance is traveled by these guys, even though they may not be going to the same location or even in the same direction. All right, so that's how things are going to get changed up. So we have a southbound bus in example 1 that left Fort Walton Beach at 9 a.m. 2 hours later, a northbound bus left the same station. So these guys are going in opposite directions, right? We've got this guy here that's traveling northbound, and we've got another guy that's traveling southbound. So going in completely different directions. It says that the buses travel at the same rate, and they were 352 kilometers apart at 2 p.m. So they're traveling these distances here, and what we know is that this total distance is 352 kilometers at some point in time. Okay? So how long, this is the northbound. And this is the southbound. All right? How long did it take the northbound, are they both buses? Yeah, bus. How long did it take the northbound bus to get to this point here, per the problem? What time did the northbound bus leave initially? Leave its location? So the southbound bus left at 9 a.m. 2 hours later, a northbound bus left. The same station. So what time did it leave then?
11.
11 a.m. If we have this distance at 2 p.m., then does everybody see it was 3 hours that it took the northbound bus to get from here to here? Right? 11 a.m. to 2 p.m. This one left at 9 a.m., so it took the southbound bus 5 hours to get to where it was going. Okay? You guys with me so far? So here's what we know. If we think about the northbound bus traveling a particular distance and the southbound bus traveling a particular distance, what does this equation here equal? Or what would this equation be? What needs to go on the right side of the equal sign?
We're trying to find which one?
Complete this equation for me. This is the distance the northbound bus traveled. That's the distance the southbound bus traveled. 8. This distance, you're looking at time. What would the distance, the total distance be equal to?
352
It's
kilometers.
the 352, right? That's the full distance that they traveled. Good. 352 kilometers. Everybody see that? Just putting some values for these guys. This is the time that the northbound bus took to get there, 3 hours. The time the southbound bus took to get there was 5 hours. Is there anything else as we read the problem that we can, any other equation that we can write down based on what the problem says? I'm going to read it one more time. A southbound bus left Fort Walton Beach at 9 a.m. 2 hours later, a northbound bus left the same station. If the buses traveled at the same rate and were 352 kilometers apart at 2 p.m., find the rate of the buses. What else do we know is true about these buses? It's the third variable that we haven't written on the board.
Have the same rate?
They have the same rate, right? So, whereas when we were doing the problems before, the last problem, right, we had distances that were the same. For this problem, Rn is equal to Rs. Does everybody see that? The rate of the northbound bus is equal to the rate of the southbound bus. So what did we say our rate equation was? Our rate equation, we said distance equals rate times time. And so rate is distance over time, right? That's the miles per hour as we think about that. Our rate is in miles per hour, so distance over time is rate. So what we could actually say is that if this is true right here, it means that the distance n over the time n has got to be equal to the distance s over the time s. Do you guys see that? I just took what's true right here and plugged it in for each of the r's. Right? Rn's got to be equal to dn over tn for this equation, so and rs has to be equal to ds over ts. Okay? So we can plug some numbers in here based on these values, and we can say dn is equal to, dn over 3, because tn is 3, and we can say that equals ds over ts is 5. I don't like those fractions. How can I rewrite that without the fractions? Nobody knows? Does anybody know how you would solve for x if I had it? How would I solve for x? I think you said it. What? Cross multiply, right? We would say, oh, this means that 4x is equal to 15. We can do that here. we can cross multiply and say that 3 ds is equal to 5 dn. That looks much nicer. I like that. That's much more manageable. So now we have two equations, this one and this one, with two unknowns. We can use the same thing we've used in the past, substitution or elimination, to solve those guys. Which one do you want to use?
Elimination?
Do you want to use elimination?
Well,
He says. But he said it's elimination.
oh, it's substitution.
I like substitution. Let's solve this guy for one of these guys. That'd be pretty easy to do, right? So dn is equal to 352 minus ds. That was pretty easy. And now let's substitute that value in right here. So 3ds is equal to 5 times dn, which is 352 minus ds. All right? So we multiply the 5 through, 3ds is equal to, oh man, what's 5 times 352?
I have no idea.
Moo.
I would guess.
Where's your calculator?
3 times what?
352.
1,000.
760.
17760.
Yeah.
I was gonna say.
All right,
like
minus
1,600.
5ds. All right, we'll move the 5 over, so we have 8ds is equal to 1760. What's 1760 divided by 8?
222.
What is it?
220.
220? All right, so the distance that the southbound traveled was 220. All right, 220 kilometers. What did the problem actually ask us for? They wanted to know the rate of the buses. Do we need to solve and figure out what dn is if the question asks us for the rate? They're traveling at the same rate, so do I need that? I don't need it. All I need is, now that I know how far the southbound bus traveled, and I know that it took it 5 hours to get there, then the rate of the southbound bus is the distance the southbound traveled over the time, right? That's what this equation here says. So distance was 220 kilometers, time was 5 hours, so 220 divided by 5, is that 44?
Yeah.
Yep, 44. 44 kilometers per hour. So that was the rate of each of the buses. Not bad at all, right? Pretty easy. You guys could do this in your sleep.
Totally.
I don't know about that.
I don't know about it in my sleep.
I bet
but
you'll dream about it
definitely while I'm
tonight.
awake.
And you'll always get it right.
Maybe half awake.
Half awake, okay.
Let's go for half
Alright.
awake.
I don't know, it might be a better experience in your sleep, right? It's like you get everything right in your sleep, no mistakes. Do you get everything right when you do it at home?
No.
No.
There's no
Not necessarily.
Or the opposite could be true. It could be one of those stressful dreams where nothing you do is right. And
You can get everything right if you check your answer. Like after you solve it, you plug it in, and you'll always use that answer because you'll
Get it
you'll
right
know if
eventually.
it's wrong.
Every time.
Yeah.
If you don't know how to check your answer.
Well then.
Get
you
someone
can-
that does.
Yeah, get someone that does.
all right, let's do one more
Anyways.
where they're traveling. They're not traveling in opposite directions. Well, I'm sorry, they are traveling in opposite directions, but they have different starting points. So let's make sure that we don't get confused with that. All right. All right, so we have ships that were 400 miles apart at midnight, and they were headed directly toward each other. This is not good, right? They collided at 8 a.m. This is just getting worse.
Did anybody survive?
Find the speed of both ships if one was 20 miles per hour faster than the other and no one survived.
Oh my goodness.
Okay, they didn't actually say that. I have that on there. No. Everyone survived. There we go. We'll make a happy ending, right? This is not a Titanic problem. This is there's a happier ending.
Wait, one ship was faster than the other? Is that all it said?
Well, one was 20 miles per hour faster than the other. Okay. So they were 400 miles apart. So this is what we know. One was over here, one was over here. They're traveling towards each other. We don't know exactly how far they travel. I mean, how long it took them. Well, actually, we do know how long it took them. We don't know what this distance was here. But at some point they collided, right? And we know the total distance was what?
400 miles?
They were 400 miles apart. That's right. So the total distance here is 400. All right. And they were that far apart at midnight, and they collided at 8 a.m. Right? So what was the time for each of these guys? The time for ship 1 and the time for ship 2, for both of these guys, it was 8 hours, right, to get here. Everybody see that?
What kind of ships were they?
We're talking about trains.
No, we talking cruise ships full of people.
Oh, I thought we were talking about trains.
I thought we were talking
Like
about kind of
ocean
ships,
ships.
like wooden ships.
Now.
How big were the ships?
It doesn't
We
say.
talking 2,000 people
Doesn't
per
say.
ship.
Per ship.
Per ship. Nobody survived.
4,000 people.
Damn it.
No, we had a happy ending. They all survived. Okay.
One
It was
were
just
died.
they collided, but it just kind of just
Well,
kind
why
of skimmed
don't
by
we
each
call
other.
the ones and only half of them died? Because you
You
Caleb.
guys are they're so violent, and you know.
Everybody in half of them. Half of them. Ghost ship?
Shit.
So
Shit. On the ocean.
Half of it was left.
you drew one. Good.
I drew.
All right. So the ship speeds. It says one was 20 miles per hour faster than the other. Which one was faster than the other? Do we know? We don't know. So does it matter?
Yes.
No.
It really doesn't with the way this problem is set up, right? We don't care because the time is the same. We're just going to say the speed of one was 20 miles more than the other. So we'll just do this. R1 equals R2 plus 20. Does that sound good? The rate of one was 20 miles per hour more than the other. You like that, Caleb? You okay with that?
Yeah. That's
Yeah?
not what I did, but yeah. No, yeah, it is what I did.
Okay.
No! Wait, it's not. No, wait, it is. Wait a minute.
Either you have R1 equals R2 plus 20, or you have R2 equals R1 plus 20. Which one?
I know, but I did it backwards, so what's the difference? I have R2 equals.
You want me to change it? Would that be easier? I can erase mine very easily. No, you got it. Yes.
May I use the rest of it?
Mm-hmm. Yeah. All right, any other equations we can write down here? That's not enough, right, to solve anything. We need two equations with two unknowns to solve it. And what are we trying to find? We're actually trying to find the speed. So we're trying to find those rates, but I'm never going to find that without one more equation. So I've got two unknowns. I need two equations.
Would it be T1 plus T2 equals 400?
Would it be?
The time, 8 hours plus 8 hours equals 400.
No, I don't know. I'm just throwing something out there.
Yep.
Would it be D1 plus D2 equals 400?
Okay, well that is true, right? We don't know what this distance is or what this distance is here, but we do know that D1 plus D2 has to equal 400, right? So now I've got two equations with four unknowns.
That's confusing.
That's not going to be a lot of help, but I do have a formula for distance that says distance is equal to what? For anything, for anything, give me an equation that has rate and time in it. Distance is what?
Times time.
Rate times time, right? Z equals RT. So we could rewrite this as R1 T1 plus R2 T2 equals 400. Does that make sense? And then we can plug in our T1s that we have. So 8R1 plus 8R2 equals 400. Right? So now we've got two equations, this one here, with two unknowns, and we can just plug in values and figure it out. So let's plug in, substitution seems like it's gonna be the easiest way to do these pretty much every time. Let's plug in this equation for R1, 8 times R2 plus 20, plus 8 R2 equals 400, sorry. That becomes 8 R2 plus 160 plus 8 R2 equals 400. Combining the R2s together, we have 16 R2. Move the 160 to the other side. What's 400 minus 160? 240, right? And then what's 240 divided by 16?
Number.
Mm-hmm.
But what number is it?
Tell a question.
240 divided by 16.
What's 240 divided by 60?
12.
4. Ha.
That's not right.
Did I still
Not right.
Yeah, it's not.
240?
240 divided by 16.
Oh, 240 divided by 16.
12.
Oh, I put 60.
Would that be 12?
Well, 2
Times
times
10.
15.
116.
Keep
Figure it out
saying-
first.
You got me a Coke and
I know.
what's it
Yeah,
called?
here's your code.
15.
Yeah, you know what, it's
$7.
15.
It's got to be, yeah, 6 times 5 ends in 0, so it's got to be something. 6 has to be either 5 times 5 or. Alright, so R2 equals 15. So if that's the case, and what did it ask us to find? The rates of each?
Mm-hmm. No, the speed.
Well, which is the rate?
Yeah, yeah.
Right?
So you just plug it in.
So this is miles per hour for R1, and then we plug that in right here, and we get, I'm sorry, that's R2. We get that R1 is equal to 15 plus 20, which is 35 miles per hour for the other. There you go. Nicely done. Nice, yes. You guys, give yourself a big round of applause. I feel like we covered more in a shorter period of time without the other people here. What do you guys
Yeah.
think?
It's
They're
Adam.
dragging us down.
She's the
They're dragging
problem.
us down.
It's gotta be Evelyn.
Oh man, Emily's gonna make you watch it. I don't know. We'll see. But she's gonna see that here that you guys blamed her.
Boo.
All right. Who actually blamed her? Eli, Caleb,
Hudson
I
said
did.
it
I
first.
Hush
Brian
money,
did not.
hush money,
Everybody.
hush money.
Hudson
Brad
said
did
it
not.
first.
Everybody.
All right. You guys have a great day. Hope the play goes wonderful.
I love you.
Are you gonna go
Mr.
see
Walker,
Windows
are you
sometime?